You learn the basics of Python and the core concepts, and then we will jump into Web3 and blockchain. And once we explain blockchain, we will start looking at how we can connect to a blockchain and interact with it with Python, so that it is more practical than having like a long theory class that you probably don't need. And then before you come and even write code. But there are times when these explanations will be necessary for us to be able to understand what we are doing before we get into it. Right? So right off the bat, let's talk about programming and programming languages, right? So programming basically, like I said last week, everything is a program. Join the everything is a program section. I said that programming basically is giving your computer a set of instructions and making it do things that you want it to do, right? Now imagine if you had a friend, right, or you had someone who works for you, and their job is to follow instructions and execute them as you want them to. Or imagine, for mommy's the only lady here. So imagine if you had a cookbook, right, and you wanted to make the same cake that is shown in the cookbook, you have to follow a recipe, right? And normally that recipe is written down. And if you miss anything during um, the the cooking, process, or if you miss anything during the execution of the instructions that you've been given, then things are not going to turn out the way you expect them to turn out, right? And believe you me, with these two analogies, I have explained what programming is, right? Now, in order for you to give effective instructions, you need to write these instructions in a language that whoever is receiving the instruction understands. If they don't understand the language, then your instructions are definitely not going to follow, and you're going to have a lot of confusions. If you go to church, it's going to be like the Tower of Babylon situation, right? So you don't want that happening, because languages are being mixed and people are getting the wrong information, or people are not getting the information at all, so they can carry out that instruction, right? Now, also imagine if you spoke in a clear language, or you spoke in a language that the person understood, but the grammar was wrong or the words were mixed up, right? Again, the person might be hearing you speak their language, but they still can't follow the instructions, or they may follow the instructions and hit a roadblock, or not be able to even finish their duties as you'd expect them to, because of a misunderstanding or a confusion in how the instructions were presented. So again, in order to write this instruction, you need some medium to write it on. If you have worked with a cookbook before, it's normally in a book, but it's normally a set of instructions for a recipe on a page, right? Which is essentially a file. Or if you're writing instructions for someone to follow at work, which is something that oracles and individuals here interact with every day on our Google Docs, those things are written out clearly, and they are written down on Google Docs or Microsoft Word or in some other form, right? It could be written on cards, or but whatever the situation is, you could have one of two instances. So you could have the instance where you say one thing and the person does it, and then you say one thing and the person does it, and then you say the next thing and the person does it. But that'll be tedious, because it's like every time the person has to wait for you to say something before they do it, right? But imagine you wanted the person to carry out a complex set of actions, right? And you wanted to give them an instruction. The most efficient way would be to write all that instruction down in a file, or to send all that instruction in bulk, right? And arrange them in the order in which you want the person to follow these instructions, right? And so do this first, do this second, do this next, do this next, now do this, now do this, now do this, now do that. We have ended. These are the instructions I need you to follow, right? Which is a more efficient way, and which is also um, a clearer way to communicate, as opposed to saying one thing and then having the person carry it out to the end before you say the next thing. Essentially, you're doing the exact same thing, but because of the way it's done, you don't have to be actively involved anymore, because you found a way to put down the instructions that you want the person to follow, right? If you use a tool like Google Docs or Microsoft Word or whatever the platform or whatever the tool is, you sent it to WhatsApp, whatever the thing is, you sent it in a certain way that the person can access and the person can follow and carry out your instructions. The last thing I'm going to say is that sometimes we can receive instructions in a different language. Like on the WadaGh platform, we work with people from French-speaking countries. On one of the other conferences that we're in, there were people that even were speaking Portuguese, and there were people that were speaking Spanish, right? And these people are speaking different languages, and um, we all have to be able to communicate with each other, even though we speak different languages. My Spanish is very bad, and I don't speak Portuguese at all, right? So imagine somebody spoke Spanish or Portuguese to me. Then I would need someone, or somebody gave me instructions in Spanish or Portuguese. Then I would need someone or a tool to take that, interpret it into a language that I understand so that I can follow those instructions, because those instructions need to be followed, right? And that will make it more efficient for me to follow, as opposed to trying to figure something out. Because one thing that means something that means one thing in another language might mean a totally different thing in a different language, right? And it could cause a lot of confusion, right? And these are the key principles of programming, believe it or not. So I'm going to take this and I'm going to apply it to programming, right? So first, I said that programming is the process of giving instructions to a computer to follow in order to achieve a desired result, or in order for the computer to come up with an expected result, right? Um, so much like the cookbook or the instructions that you're giving out to someone to follow in order to come out with a right result. First, you need to write it in a language that both you and the computer can access, right? And this language is called a programming language, right? And there are so many programming languages out there that all computers or most computers can easily understand, right? Or can easily access. That is the right word. I won't say understand, and you will get why I won't say understand very soon. So can easily access, right? And much like we have Spanish and Chinese and Korean and Chi and Ga and Ewe and all those languages out there in the world, the same way there are several hundreds, right, of programming languages out there that people use on a day-to-day basis to give their computers instructions, right? And so the one that we are going to be learning is Python, right? But the other programming languages like Java, Haskell, Scala, Go, Julia, uh, so many languages out there. I can't even begin to mention all of them, right? There's Ruby on Rails, there's uh now there's that from Google, and there are other programming languages out there that people are using on a day-to-day basis and if you've interacted with any interface at all, like this interface you're looking at right now was predominantly built with JavaScript, right? Including the animation you're seeing on your screen of me talking and all the pulsing around it. All of this was built in JavaScript, which is a programming language, right? Now, so you need to speak to your computer in the form of a programming language, right? And which is JavaScript. In order for you to be able to effectively give the instructions, there are two ways you could do it. You could give one instruction after the other for your computer to execute, which is something you can do in your terminal. Or you could give a bulk of instruction, right? Which we say you write a script or you write a source code, right, for your computer to follow. So it's like you're talking to your computer, but you could say one thing for your computer to follow and another thing for your computer to follow, or you could say everything all at once, send it to the computer, and the computer will read and follow it, right? But here's the catch. You need a medium to write it in. You need a medium to write it effectively. Now, imagine if you wanted to write something to someone. you wanted to put emphasis, you wanted to bolding, you wanted to do all those things. And the only tool that you had was the text tool, right? The only tool that you have was Notepad. That would suck because there's not enough formatting tools in there for you to be able to write the documents the way you need to write it for the person to follow, right? And that would be very, 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 very frustrating. But thank God we have tools like Microsoft Word. Thank God we have tools like WP Office. Thank God we have tools like the Linux Office, LibreOffice tools. Thank God we have tools like Google Docs and all the other tools out there that people day to day use for writing documents out for people to be able to communicate with them and understand them, right? Much the same way, in order for you to be effectively put those instructions down, you need a tool to write it in. And this tool we either call a code editor or an IDE, right? Now, what's the difference between a code editor and an IDE? A code editor is the tool like Word or Docs or that you actually use for the writing. A simple tool editor could be Notepad++, and there are some other editors out there, right? Now, the one that everybody installed in this program or has installed so far in this program is Visual Studio Code. Visual Studio Code is basically a, a, a code editor, much like Word or whatever, with specific tools for us to be able to more efficiently write code and format the code the way we need to so our computers can understand the code, right? One company that makes the best IDEs in the world is JetBrains. JetBrains makes some of the finest Python IDEs in the world, and their most popular is PyCharm, right? Which is the IDE that I use. You realize that I switched from a code editor to an IDE. Now, PyCharm, most code editors, you can switch to and write only one code at a time. But for an IDE, IDE stands for Integrated Development Environment. If you want to develop things more efficiently, where in some cases you have two or three different programming languages talking to each other, and you have these talking to Markdown or interface language, then you need an IDE because the IDE should be able to understand all the programs that you are, all the languages that you are speaking, and should be able to put them in a way that connects all of them and should be able to help you format all of them at the same time without affecting your speed or your progress, right? Visual Studio Code is essentially a code editor. It's where you write the instructions for your machine to follow, right? But that instruction that you're writing has to be written in an environment where you can write it more efficiently, more quickly, and you can write it in a way that makes your life easy as a developer, right? Or as just somebody who is writing code, because I don't know whether all of us want to be developers. Okay, so that said, now I'm going to talk about the catch. The catch is that your computer actually doesn't speak all those programming languages that I mentioned. Your computer only speaks one language. And the language that your computer speaks is binary. It's a language that consists of only two alphabets, if you like. It's zeros and ones. And basically, or two digits, zeros and ones. And basically, these zeros and ones are combined in several different ways in order for you to be able to see and interact and get all the results that you're getting. So, believe you me, you are looking at this interface. There's a lot of complex things going on here, right? If you look on your screen, probably in your browser, you have three tabs open. You have different colors showing up. You have different shapes showing up. You can hear my voice at the same time. If I open my video, my camera, you can see a video of me at the same time, and everything is happening all at once, right? Under the hood, what is happening is that Zeros and ones are being used to switch on transistors and pixels and things and everything. All is zeros and ones. Zero for off, one for on. And it's being used to switch all these things on and off in several different ways, such that even the P you see on your screen is represented by a code. We call that code bytes. So it's a combination of zeros and ones at a certain length. I don't want to go deeply into that. But basically, that's the language your computer speaks. In order for your computer to be able to speak that or to understand what you wrote, right? The Python code that you write needs to be translated into zeros and ones in order for your computer to be able to give you the results that you're looking for. And the way that gets done is through a compiler or an interpreter. In Python, we say interpreter. So you see the Python software that you installed. The Python software that you installed on your PC is not the Python code, if you like. It is the Python interpreter. It is going to look at what you've typed, take it, interpret it into binary, or interpret it into an intermediate language, which then gets compiled into binary. And that binary is what your computer executes. It's what your computer actually understands and uses it to give you that effect, right? Now, are there any questions at this point before I go on? I've given you two analogies. I've used that analogy to explain what programming is, what a programming language is, what an interpreter is, and what a code editor is. Do we have any questions at this point? Hello? No questions?
No question from me there.
Okay. All right, awesome. So we're going to go on. Now I'm going to demonstrate two things, and I would ask you to follow along if you already have Python and everything installed, right? So I said that if you want to give instructions to um to your computer, right, or to someone, you could say, if you have a long set of instructions, you could say them one after the other, and then have your computer follow what you're saying one after the other. So you say one thing, your computer executes it. Then you say the next thing, then your computer executes it. Then you say the next thing, then your computer. Or you could write this entire message in bulk and have your computer read through them, even when you are absent, and execute them. Right. So this is what we are going to do. I want you to go to your search bar inside your taskbar, the search inside your taskbar. Again, type CMD to open your command line and press enter. If you do that, you should see your command prompts pop up like this. Do we all have that? If you have that, just type it in the chat so I know you do have that.
Have it, but you're not sharing your screen, so could you do that so that everyone can know what's going on or how it's actually supposed to be done?
Yeah, I'm sharing my screen now. Can you see my screen now? Actually, wait, let me share my entire screen. Awesome. So I'm going to go over the launching of the command prompts, right? So go to the taskbar, click on the search box or the search icon, depending on how it's organized, and type CMD, right? When you type CMD, open the first option that pops up. It probably is the only option, which says command prompt. Click on that, and then you should have this pop up on your screen. So you should have a console like what I have right now pop up on your screen. Do we all have that? Okay, awesome. Okay, nice. So in order for your computer to understand that you're about to write Python code, you first need to type py, or you need to type Python. Either way, it should open up a prompt like this, right? This is what we call the Python prompt, or it should open up a Python console for you. Do we all have that? Okay, awesome. So if you have the Python console, once you do this, now you can start giving your computer instructions. So now that you have this, the nice thing about Python is that for some languages, you need to define a lot of things before things start happening. But Python is a scripting language, so it's quick. Everything is set up for you out of the box, right? And the nice thing about it is that Python is a highly logical language. We say it's an explicit language, right? You need to say exactly what you want to say. And it's a highly mathematical language, and it has all these things already built into it, right? And so right off the bat, we can start doing math calculations with Python without even importing any, sorry, without even importing any special packages, right? So I can just say 2 plus, sorry, 2 plus 5, which evaluates to, and if I hit enter, it is going to look at 2 plus 5, and my computer is going to, and it's going to send that to my computer. My computer is going to do the calculation and return the right value to me. So if we type 2 plus 5 and hit enter, it should evaluate to 7. And you should, I don't know whether you can see my, let me see if I can make this big. Nope, I can't. But you should have 7 show up right under the prompt, and then a new prompt should pop up. Can you see that?
Yeah, I can.
Okay, all right. Have we all been able to do this simple math? Or some of us used our calculator? Okay, awesome. So play around with it. We can now take the 7 and add 3, and it should evaluate to 10, right? And we can do 3 divided by 2, and it should give us 1.5. And we can do 3 times 5, right? And plus 2 and minus 4, right? So basically 35 is 10, plus 2 is 12, minus 4, sorry, 3 times 5 is 15, plus 2 is 17, minus 4 is 13. If I'm wrong, the computer will show me up for it, right? So you should get 13 return, right? So right off the bat, you can do all these complex math right off the bat and like show it, right? So that's the nice thing about Python. It's a highly mathematical language, and so you can do basic math even up to some points where the math is complex and all that, right? Or you can give an instruction like name equals, and then just do what I'm doing for now. So do double quotes, and then go in that, do name equals. Let me do this well. Name equals quotes. Easy. You could use your name, right? And close that quote like I have on my screen. Have we all been able to do that?
You said name equals what? Prompt?
So name equals, right?
Mm-hmm.
And then open quotes,
Mm-hmm.
and then put your name there,
Okay. And
and then close quotes,
quote it just okay. If here and close it. Mm-hmm.
and then put your name inside and close the quotes, right? And then hit enter. Nothing happens, right?
Yeah.
Basically, what you did was to tell your computer that create a box called name and store the name Ifya in it, right? Or store the name Ebenezer in it, or store the name Richmond in it, right? We've done this in math the whole time, but we don't realize that that is what we do, right? So basically what we did was we said take a box, label that box name, and the name I want you to put in that box is Efia, and store it. So right now your machine is storing the name Efia or whatever name it was you decided that it should store, right? So if I
Mm.
type name, if I type just name, right? Because I've said the name I'm storing is Afia. If I hit enter, it should return my name, right? If I type name, every time I type name and I hit enter, I can type it 100 times and it will return name because now my machine is storing that as the name. So all I'm doing is I'm telling my machine, again, we're giving a set of instructions, right? I really want this to go down really well. That programming is just about giving a set of instructions. So what is happening is that I'm giving my machine an instruction. I first started by telling my machine, what is 2 plus 5? Now, what is 7 plus 3? Now, what is 3 divided by 2? Now, what is 3 times 5 plus 2 minus 4, right? Now, I'm telling my machine, create a box called name or create a variable. That's the right name. We'll come to that. Create a box called name. Now, take the name easy and store it in that box. And every time I ask my machine what is in the box name, it returns that name to me. Every time I say what is in the box name, it returns that name to me, right? Now we could say now name equals again, and then we'll change the name, right? So we'll change the name to, I'm changing mine to our president, right? So now what I'm telling my PC is that now take the name easy out of the box and replace it with Nanado. And I don't want you to worry your head over what all this means. I just want you to give the machine these set of instructions so that we can demonstrate what I just explained earlier on when I was doing the explanations about programming languages and everything.
So you said programming is giving what, a set of instructions.
Instructions, yes, to your computer to carry out or to a machine to carry out.
Okay.
So now write name and do the open and close brackets again, and in between them put a different name, right? So if you press enter again, nothing happens. What we just did was to tell the machine, now take the name easy out of the box and store the name Nanado there, or whatever name it is you choose to store there, right? Now if I go in there and I type name, I ask my machine for the name again, it's going to return Nanado now, right? If I go in there and I ask it, oh, I typed it wrong, and I ask it name, it should return Nanado over and over and over again. So give me name, Nanado, give me name, Nanado, right? That's what we're doing. Now let's do something more complex. Did we all get this part of the concept? Hello? Okay, awesome. Now let's do something more complex. Let's do something more exciting, right? Let's let's create a program that allows our computers to calculate our age based on our date of birth, right? I mean, you could do that. You could just sit down and like do that, right? But again, you could also tell your computer to do that. You could say um current year. No, you can't do this. Current year, or yeah, let's just do current year, or let's call it this year. So type this underscore year
At the
equals.
prompt, at the prompt command,
So where the prompt is, type this underscore year, no spaces,
this
equals
underscore
this year, year
year. Okay.
equals 2023, right?
Yeah.
So you are saying that PC, take a certain year and store it, right? So create a box called this year. And inside that box, I want you to put this current year that we are in that box. So that's 2023, right? Now note that when I was typing the 2023, I didn't put any quotes around it, right? And we will explain that when we start exploring data types. Right now, we're just giving our PC a set of instructions to see if it's going to return what we expect it to return. Note that every time I wrote a number, I didn't put quotes around it. But every time I was writing something that was supposed to appear as a text, I put quotes around it. That is because your PC understands this in different ways. And we'll talk about that. But for now, let's build a simple program that allows us to calculate our age based on when we were born, right? So if I say do that and I press enter, again, if you did everything right, the prompt should appear with the cursor blinking without anything happening. But what your machine just did was to take the year 2023 or the digits 2023 and store it somewhere with the name this year, right?
Okay.
Now you want to type YOB. You want to create another box, call it
So should we
YOB.
enter?
Yes, press enter and then let
Okay.
the prompt appear. Yes.
Okay.
And then create another box called YOB. And then inside that YOB, put your year of birth, right? I'm going to lie and say I was born in 2012.
So how do you create? You said you should create another box. How do you create another box?
Oh, just by calling it what you want to call it. But we want to use the text YOB, which will stand for year of birth, right? And
So
then
should,
equals.
okay, you go on.
So YOB equals 2012 or whatever the year of birth is that you want to put in.
So
Nobody.
wait, so the cursor is blinking now after I entered the 2023. So I
Yes. So
just
now
go
you want
ahead
to type
and type
YOB
YOB. Okay.
equals 2012 and press enter again.
And press enter again.
Yes.
Okay.
Okay. Again, if you did everything right, your cursor should just be blinking. So now we've stored three things. Now we've stored three things. Note, we stored um we stored the name. So if I type name again from here, Nanado should pop up. So we've stored name, right? That's the first thing we stored. We've stored this year, which is 2023, and we've stored year of birth, which is 2012, right? These are the three things we've stored in our PC, right? Now we want to find out whether we can write a program that calculates age. And we just say age is equal to this year, right? That's how you calculate the age. Is this year minus year of birth, right? Note that I didn't type 2023 minus 2012, but I referenced the boxes in which these values whatever is stored into it. So I'm referencing this year instead of 2023. And I'm saying that now go into the year of box and find what is stored in there, which is year of birth. And then subtract year of birth from this year. If I hit enter again, nothing happens because again, I am taking these two boxes and I am I'm taking the values in these two boxes. I am doing something with that by subtracting one from the other, and I'm putting the result inside another box called age, right? So I'm going to go over again. We stored name, we stored this year, we stored YOB. Then we created another box. But inside this box, we said that take this year, subtract year of birth from it, and store it in this fourth box called age, right? So now, if you type age, if everything worked right, what is stored in this year is 2023. What is stored in year of birth is whichever year of birth you decided to use, which in my case is 2012, and you hit enter. It should give you the difference between 2023 and 2012, which is 11 years.
It's not working for me.
Mommy, please, what happened?
Okay, so um, I type age minus this year equals to this year minus YOB, and I entered, but the cursor is just blinking.
Yes, because you have stored the value inside age. Please, do you understand what I'm saying?
Oh,
So I'm
okay.
going to repeat.
So how do I get to see the value?
Just type age. Now ask the computer for the age.
So I type
By just
age
age
and
and
then
press enter.
I got it. Hey, I got it.
Okay, please, if you've gotten it, just send me an emoji or just do something to let me know you've gotten it up to this point. Okay, now we're going to write something super complex. Not super complex, but we're going to make the machine return stuff in a certain order, right? And then we are going to make the machine say something very interesting based on all the things that we have entered right now, right? So in order to make the machine say something or the machine output something, right? You use what we call the print function. You're telling your machine to say something. You're giving your machine direct instructions, right? So I'm going to do this very quick. Again, this is just writing our first program and getting a feel for giving instructions to machines. And so don't worry about what your typing means or whatnot. We'll delve into that. But right now, we want to focus on just giving instructions so that we have a very good idea and a demonstration of the concepts that I explained earlier on: a programming language, an interpreter. So in this case, the Python interpreter that you open is receiving it, passing it on to a machine in a language which it understands, and your machine is in turn executing those instructions that you're giving it, right? And the Python interpreter is what we are in right now with the cursor blinking. So we are just demonstrating these ideas, right? And we are demonstrating the first instance of giving an instruction. You realize that these instructions that we are giving, we're giving them one after the other, one after the other. And in each instance, we are, you realize that these instructions that we're giving them one after the other. And in each instance, we are receiving a certain response, or we are receiving a certain result, or the machine is is following those instructions and doing exactly as we told it to do, right? But we are doing it one after the other. So this is a case of the this is an example of the first case of giving instructions that I spoke about. You say one thing, the machine executes it. You say another thing, it's inefficient, but it's going to get the job done. So in order for us to just allow our machine to say something, you want to type print like this. So what I was saying was that now that we understand that we're giving the machine instructions, we can also just make the machine print out, or if you like, say whatever we want it to say, right? We can make the machine do that. So in order to do that, you start with the instruction print. Once you type print like this, your machine knows that you want it to say something. Now it's waiting for the instruction it's waiting for the instruction on what you want it to say, right? So in order for you to give the instruction now, you want to open a bracket and open a quote, right? And one of the first programs that everybody is told to write is hello world, right? Exclamation mark, and then close the quotes and close the brackets, right? So if you do exactly what I have done and you press enter, your machine is going to return hello world, because this is a direct instruction that is saying say hello world, and your machine is going to say hello world. Please, if you all have it, you give me an emoji. So what we are going to do is that if we write a set of instructions and I ask whether you have it, just give me an emoji so I know all of you have gotten it. Okay, awesome. So again, we're giving instructions to the PC. We are making the PC say stuff. Now, remember that we made the PC store our name. We've made the PC store this year. We've made the PC store our year of birth. We've made the PC store our age, right? Now we're going to make the PC say all these things without directly referring to them. We're going to refer to the boxes in which they are stored, right? And how we want to do that is to tell our PC to print a bunch of things out, right? So we're going to say print, and then we want to open a bracket, open a quote, and say, hey, sorry, hey, exclamation, my name is, right? Close the quote, put a comma there, space, and then name, right? And then close the brackets. If you do it right, if you do it exactly how I've done it, hopefully it should say, hey, my name is Efia, or my name is Richmond, or my name is Kofi, or my name is Ebenezer. So basically what we did here was to tell our computer to say, print, hey, my name is, and then go to the box where we stored name, right? And whatever name is currently in it. In my case, I changed the name to Nanado. So whatever name you change yours to in the second instance, it's going to take that current name and print it out. That is why we reference name here, right? So your computer will say, hey, my name is Efia, or hey, my name is Richmond, right? Okay. All right. Now let's have fun with some of the more of some of the instructions, right? And the next thing we want our computer to do is to print. So print again. Sorry, no capital. Print. Print again. Open brackets, right? Open quotes and say I was born in. My born says born. I was born in. Close the quotes here. Put a comma, right? And then put your YOB there, which is the year of birth. Again, and then close the parenthesis. Again, we're telling the computer, now say that I was born in, go to the box called year of birth, and whatever year we have stored in there, print it out. So just basically say, hey, I was born in, and then hit enter, and then it will give you the year of birth.
Hello, Ezekiel. Hello, can you hear me?
Yeah,
I realized that
yeah, I can hear you.
the comma is very important because it separates the it separates what you want from the boxes that you have created itself. I tried.
Yes, so I'm going
I
to
am I am 20 years old as per the boxes I've
Mhm.
already created without the comments, and I realized that I had syntax errors.
Yeah, exactly, right? So we're going to explain all that when we actually start talking about the concepts. So again, we are giving our PC a set of instructions, but this is not ideal. It means that you have to say one thing for your PC to execute and say another thing. Now imagine if you have 10,000 things to say, or imagine if you have even a few hundred things to say. It means that your PC just have to keep executing and executing, right? You give these set of instructions, and the moment you close that, the moment you close your command prompt, it's gone. Your PC doesn't have these instructions. You can't store these instructions. You can't save it. And as a proof, let me open my command prompts again. CMD. Let me go full screen. And then I'm going to type Python. It's going to open the console. And I'm going to say name. This has been forgotten by my PC. My PC is going to behave like I have never told it to do this, because I gave a set of instructions and that was it. It followed the instruction, it's executed it, and that was it. It cleared it from the memory. So if I hit that, it's telling me that most recent call. It's saying that what you're calling name is not defined. I don't know anything called name that you're asking me for. That's what basically what it's telling me. I don't know what you mean by name, right? Because you've not defined it. You've not told me what name is. But if I say name equals, and then I come back and I say, let me type my traditional name, right? And I hit enter, then it will now store it. And when I say name, then my PC is going to say, oh, okay, all right. So you want me to now save your name as this, and then if you ask me for it, I should return name to you, right? So basically that's what is going on with my PC. Again, I said that all we've done is the first instance, right, of giving instructions, which is you can give one instruction, wait for the PC to execute it, and give the next instruction. And that's not effective. Imagine if somebody to do a certain specific task, and you wanted to cook a certain food that you've never cooked before, and you wanted to have the ability to cook that food over and over and over again, and all you did was to get verbal instructions on how to cook it one time, right? And it wasn't written down, it wasn't there again, and then like some months later you want to cook the same food, right? You might end up messing it up because you don't remember all the steps, or you might end up not remembering at all, in which case you, in either case, hello.
Oh, sorry.
Okay, so in either case you won't be able to cook the food. That's not going to happen, right? Because either if you mess it up, you have not cooked the food. If it's jollof you want to cook, right, and you go and buy condo because you didn't write the instructions down, if you add everything else to the condo, you've not cooked jollof. You've cooked something, but it's not jollof, right? If you don't have the if in the other case you can't remember the recipe at all, then you can't even begin to cook the jollof, right? And this is not very efficient. If you expect to be repeating um a certain task, or you expect your PC to repeat a certain instruction, then you have to find a way to write that instruction to a document that your PC can read and execute it every time you tell your PC, go do this, right? So you could every time come here and say, do this, now do this, now do this, now do this. Or you could write all the steps down, and then you could tell your PC, remember what I told you to do the last time, go and do it. PC will just refer to that document, or you could say, remember what I told you to do the last time, refer to the document and do it. Then your PC could go read the document and execute it without any further input from you. So let's go do that. Let's go do the second case, right? And the second case is what most programmers do. We write the program. We write the program, and then we can call that program and execute it on command every time, right? So that's what we are going to be doing. So for those of us who didn't create a folder on our desktop the last time, I remember saying that create a new folder on your desktop and call it pytuts, pytuts, short for Python tutorials, right? That is what I asked you to do. If you have that, then we can start saving a set of instructions or different sets of instructions in that folder. And then every time we can go to that folder and tell our computer to execute a certain set of instructions that we've saved. Okay, so if you all have that folder and you all have that folder on your desktop, we're going to open the folder in VS Code. There are two ways to do it, right? So I'm going to go to my folder, if you can still see my screen. I'm going to go to my folder. I'm going to go, mine is saved elsewhere. I'm going to go to projects,
So
Python.
the
Pardon, yours should be on your desktop. I think mine is on my desktop. Yeah. So mine is on my desktop, right? So there are different ways to do it. You could open VS Code, open your file manager, file explorer, and reduce it, minimize the window or reduce the window, right? And then you can drag and drop your folder in here and it will recognize it and open it. That is the easiest and fastest way to do it.
so the example that we did is not a file, and you can
No, it's
drop
not
it.
a file.
Okay.
No, it's not a file. It's not a file. We just gave the PC a set of instructions on the spot to carry out.
Okay.
We didn't save those instructions. So if you go back and you try to ask Python to print name, it's not going to happen. It's going to say, I don't know anything called name.
Okay.
You're not saying anything right now. Yeah.
Okay.
So again, you want to open VS Code. You can open your file explorer in a minimal window, a smaller window like this. Go to your desktop, which should be on the left hand side of your file explorer, and then double click and drag PyTools. So double click on PyTools and drag it
Oh, okay.
into Visual Studio Code like that and release. If you release, it should open an empty space like this for you. But if you look up here in the top left corner, right beside the files icon, you should see PyTools open there, all caps. All right. So now that we all have the folders open in the code editor, now we can have some fun. So we're going to take the same instructions that we wrote and we're going to save. We're now going to create a file, save those instructions, and have our machine run those instructions on command, right? Now, every file that you want to send to someone has to be written in a certain format. If you're storing data, you have to write it in Excel, and it has to be stored in Excel format, else the person cannot open it. If you're writing a document, it has to be stored in .docs, which is the Word format, or it has to be stored in .docs is a general format, so that somebody can open it in Word or Google Docs or LibreOffice, right? So we store different files in different formats so that people that are accessing the file can open it with the tools that they need to open it. In much the same way, we need to store the files that we are sending to our computers, or we need to store the instructions that we are sending to our computers in a certain format so that our computer will recognize it and use the tool that it has to open it, if that makes sense. If we don't store it in the right format, our computer will know what it is, or the interpreter, which is the right thing to say, won't know what it is in order for it to pass on the instructions to the computer, and the computer won't be able to execute the instructions, right? And so right here, if I start hovering on the PyTools folder here, if I start hovering on it, you should see a set of icons appear to the right of it, right here. Can you see it?
Yeah. Yeah.
The
Plus
first
plus.
icon, yes. So the first icon is to create a new file. The second icon is to create a new folder. The third icon is to refresh Explorer. And the last icon is to collapse all folders in the Explorer, right? What we want to do
Yeah.
right now is to create a file to store the instructions, right? And so please click on New File. It should open a box with a cursor down there, right? Over here, your code editor is waiting for you to give the file a name, right? Call it lesson
Example. Oh, okay. Lesson one.
lesson1 dot py. We are using dot py because dot py is what allows your machine to understand that this is a Python code. If you store it as anything else, it's going to treat it like that, right? So an example, please don't do what I'm doing from here on out. If I store it as .txt, it's going to see it as a text file. If I store it as .docx, it's going to see it as a Word file, right? Because our computer only recognizes these extensions as a certain type of document, and it will read it as such. But we're not storing a Word file, we're not storing a TXT file. We're storing this as a Python file. So we store it with .py. And if you use a good PC, or if you use certain extensions, you should have this icon appear, not a good PC, certain extensions. You should have this icon appear at the edge to tell you that it's a Python file. Nonetheless, the icon is not important. It's the in which you store it. So lesson1.py, no spaces, right? And then press enter. As soon as you press enter, you should have the file open up automatically to the right of the folder, right? And then we can start storing some instructions in that file.
Yep.
Please, are we all okay up to this point? Please, again, thumbs up. Else I won't know whether somebody's
I'm okay. I don't want to do thumbs up and leave my screen.
okay, thank you
Yes,
very
I'm
much.
behind, but I'm following all that you are doing.
Okay, all right. So now that we started, we press enter. This is what happened. It opened the file to the right side. Now, there's a lot of things that happens to a lot of people when they start working with code editors for the first time. Now, just again, just in the same way that you write just in the same way that you write a Word file and you don't save it. And if you don't save the file and close the Word document, you don't get access to it. In that exact same way, if you write a program and you don't save it, the whole program is not going to get exist. In fact, if it's not saved, it's not going to exist. If it doesn't exist, and you go to tell your PC, can you go find this file? And you didn't save it. Which file are you telling me to go and find? It's not there. So what these code editors have, especially Visual Studio Code, is to allow you to automatically save the file when you do something, right? Or automatically allow you to save a bit of the code that you've written if you do something. And so let's go and set that up so that we never have to worry about pressing Control S before running our program, or we never have to worry about clicking File Save before ever running our program. All right. So the rest of the things, most of the things that you are seeing, a lot of them are personalizations now. Okay. So you can see that even the way my screen looks is a little different from yours. I have a dark blue screen, whereas
Yeah.
yours is most definitely black, right?
Black. Yeah.
All these are personalizations, just themes. Later on, if any of us are interested, maybe if we start a class like we did today a little bit earlier than the rest, those of you that are there, those are some of the things we can do. We can open our code editor and personalize it and use it in a way that we enjoy, right? I enjoy this particular theme, that's why I'm using it. Okay, so let's go and auto save our file so that we never have to worry about it again. So you want to click file, right? And then you want to go all the way down to preferences over here,
Yeah.
preferences. Go to
Yeah.
the menu that opens and go all the way down to settings here
Settings.
and click on settings. Another window should pop up on the
Yeah.
side of the Python. Yeah, this one.
Yeah.
Now over here, you want to type autosave. It should be the first thing. But if you can't find it, you want to type autosave.
So I have it commonly used autosave and it's off.
Yes, so you want to go in there and click the drop down,
And then
and then you want to change it to on focus change.
okay.
And then that's it. Just close the settings.
You just close the setting.
Yes, at the top.
Okay.
So basically what you did here was to tell your code editor that every time I shift my focus from the file that I'm currently working on to anything else. Save the code that I've written.
Okay.
That's what we've done. Otherwise, every time you write a code, you either have to press Control S or you have to go to File and hit Save before you run the code. Else, you're going to click File and you're going to run the code and the code is not going to run, right? Again, because this is a sort of an IDE, if you write a piece of Python code here that you want to run, all you have to do is to click that, the play button here. If you don't have the play button, let me know. Over here, you should have a play button
Over where?
up here. So look at the top,
Hello.
all the way to the right corner. Yeah, can you hear me?
What I'm saying is that you said there is a way where you can save the document can save automatically.
Yes.
Without you going to Control Save or going to the file and say Save.
Yes.
My question is, you said that the system can save automatically where you don't need to say Control Save or go to file and save.
Yeah.
So can you demonstrate that one and let me see how you did it? Because I can't.
Okay, so you go to File, Preferences, Settings, and then the very first box that pops up, you can see it's auto save over here, right? You want to, if it's off, you want to click on that box and select on focus change. Basically, what you're telling the machine is that if I shift my focus from the file that I'm currently working on, if I click on any other thing or I check out any other thing, I leave the code editor, check out a browser, or I get a message, I go, not on your phone, please, on your PC, or I have a Word document in the background and I check it. Please save what I'm currently doing. Every time I shift my focus from that. That's what this on focus change means. There are other options on window change. It means that only save it if I have left this window, but I don't want that. Because I could have multiple files open. I want to say that if I shift from lesson 1 to say lesson 2.py, save lesson 1 if lesson 1 was what I was working on. So that's basically, and this video is going to be up on YouTube anyway, so you're going to have access to it for as long as it exists there. All right, so now let's do some fun stuff. We're going to do the exact same things that we did inside the console this time around, right? So again, we say, I'm going to take this as writing a letter, a nice letter to your machine with instructions, right? So first, I'm going to say, again, we've not started the actual programming concepts. We will start that. I really need this to go down really well before I start saying anything technical, right? So we want to say, hello machine, create a box called name and store. Again, this time around, if you hit the equal sign and you press the quotation marks even once, it will create a double quote and put the cursor in the right spot for you. You don't have to do as much work as you did in the terminal where you had to go back and forth and create every single.
Ezekiel, please.
Hello, mommy.
Let's take your time and start. Hello, machine. The hello. Do
Yes.
we have to face the things that we are
You
writing?
you don't have to type it. You don't have to type it. I'm just saying that take this as a letter you're writing to your machine. Your machine doesn't really care about the greeting, right?
Okay.
Just
Okay.
give it a bunch of instructions and you'll do that, right? So say, again, the same things that we did, right? So we want to create a box called name. So we want our machine to create a box called name and store the name in it. And I'm saying that note that in this instance, the process, the code writing process is going to be much easier because now you are using a tool that is designed for that, right? You're using a code editor. And so if I type name equals and I hit the quotation mark once, it will create both quotation marks and put the cursor in the middle for me because that's where I'm going to write whatever I need to write. It is only after I've written it that I need to come out and press enter to do the next thing. Please, do you understand what I'm trying to say?
Go over it, please.
Okay, so let's do it again. So I'm saying that because you are using a code editor, if you weren't using a code editor, or let me just spin up a terminal and do this side by side. So in my terminal, if I call Python, in my terminal, I have to do name equals quotation Ezekiel quotation before that happens, right?
Yeah.
But on my PC or on in the code editor,
Mm-hmm.
because I'm using the right tool, because I'm using something that is analogous to Microsoft Word for humans to
Yeah.
write instructions for the machine or to write a document for the machine. If I type name and I hit equals,
Should there be space after the name? Should there be space after the
yes,
name?
yes, that's
Okay.
the right convention. So name equals, and I press shift and then the quotation marks. It's going to create two quotation marks and put the
Okay.
cursor in the right spot. Unlike the code and unlike the console where I had to type every single bit of code myself,
Yes.
right? So now I'm going to put the name in there. Okay. Another thing that we stored. So another thing that we stored was this year, right? So the same thing, this underscore year equals 2023, right? Exact same thing. So this no year of birth YOB equals, in my case it was 2012. Another thing that
Ezekiel,
we stored was,
Ezekiel,
yes,
please,
mommy.
please. This year and then the one we didn't put the quotation marks, or it's not necessary.
So like I said earlier on, if you're writing numbers, Python already knows
Oh,
that this
okay.
set of
Okay.
characters.
Okay.
So if
Okay.
you're writing numbers, they don't go in quotation marks. But if
Okay.
you're
Thank
writing characters, they need to go in quotation marks.
I need to I need to get that stuck in there.
Mhm. Okay. So now we said age was another box that we created, right? And we said age was equal to this year minus year of birth.
I like the way the suggestions keep popping up.
Yeah, it's also an extension. I need to turn that off. I don't like it when people use suggestions because if you don't know what you're doing, you could write the very wrong thing.
Yeah.
So if you are learning fresh, I wouldn't advise that you use those suggestions.
Okay, so Ezekiel, the number four,
Yes, mommy.
age. Age is
Yes.
equals that this year. Should it go into quotes
Yeah.
or just this year?
Pardon?
That this year, should
It
it go
shouldn't go
into
into
quotes?
quotes.
Okay.
It shouldn't
Okay.
go into quotes. We are referencing this box right here. So even if I start typing this, I think the suggestion should pop up in using this extension. Yeah, but this year minus year of birth, like that.
Okay.
So because I'm referencing these boxes, anytime you have to reference any of these boxes, which are
Mm-hmm.
storing things, your program has already stored everything. You don't need to put quotes around it.
Okay.
Okay. And then we printed out a bunch of things. So we are going to print all those out again, right? So we said print and then open brackets. Again, anything that is double, every time you press it, it will give you the beginning and the end, and it will put the cursor in the middle. Like the brackets also needs to be closed, right? So print, and then we said what? Hey, exclamation, right? And then we said my
No, wait.
name is,
Print space.
yeah.
Then.
No, no, it's not space.
Mhm.
Print parenthesis. So
Okay.
print open brackets, right?
Yeah.
And then quotes.
Okay.
and then hey,
Hey.
right? Exclamation.
Mm-hmm.
Don't mind what is popping up on my screen. My name is
Space. Is there
hey, my
space
name
after?
is
Is there space after the exclamation?
yes, space after the exclamation.
My name is okay.
And then come and then press right, the right arrow to come out of the quotes,
Yeah.
and then comma, and then pass in the name box. So basically what we just did was to tell our machine that go take what's the name? Go take say hey, my name is, go to the box labeled name, take the name in there and add it to that sentence, right? So it's going to say, hey, my name is Ezekiel for me. It's going to say something different for you, right? So now that we
So
have
after
this,
the comma, you said you should write a name there.
yes, but this name is referencing this
Yeah, I
box
know.
right here.
Do we put a space or we should just go ahead and write it?
Put a space there. The funny thing is that you could decide not to put a space there, in which case it will give you a different result, right? So
Mm-hmm.
if you don't put a space there, it's going to print out correctly. But if another developer has to read your code and all the code is jumbled together, it becomes difficult for them to read. So we write
The,
a code.
the reason why I keep on asking you whether space, because I know that some places they say you don't put space. That's why. So you when you are talking, just let us know whether we are supposed to space out on.
Definitely, I'll do that.
Okay.
All right. So that's the first thing we want to print, right? This time around, let's print the age, right? So we're going to say now print. Uh, so quotes I am, right? Come outside the quotes by hitting on the right arrow key, comma, space, age. Again, we are referencing the age box, so it doesn't need to go into the quotes. But comma, and then we want the machine to add another line of text to it. So we say years old. So we are saying print, hey, my name is, go and look for name, add it to that sentence. I am, go and look for the age, add it to that sentence and say I am 8 years old, right?
So if I get you right, the six, we are repeating the
Yeah.
five. Hey, my name.
No, we're not repeating the five. The six, we are saying print,
Mm-hmm.
I am,
Okay.
comma, age, comma, and then quotes again, years old.
I am, comma, age, comma, then what?
Quotes, years old. So you see the way I've written it. I start, let's go over
Just.
again.
Mm-hmm.
So say um I am,
Mm-hmm.
right?
Mm-hmm.
And then come outside of that, and then you want a comma, and then space, and then age, and then space, and then quotes again. So age, comma, space, quotes again, and then years old, full stop.
So let me go over what I have. If that is it. Print,
Mm-hmm.
then you open the bracket,
Brackets. Yes.
then the quotation, the quotes, then
Mm-hmm.
I am, then you come out of the
Mm-hmm.
quotes, comma,
Mm-hmm.
space, age, comma, then another space, then quotes again, then years old.
Yes, please.
Okay.
All right. So we're going to tell our machine to print one last thing, right? And it's going to print again. We use the print function. Every time you use the print function, you need to start by opening a bracket, right? And then quotes. We're just making our machine say a bunch of stuff, right? So this would be fun. Anyway, that's fine. So say I was born in, that goes inside the quote. You come out, you comma space, and then year of birth, YOB.
Okay.
So basically we are saying that take a certain value for name, which is Ezekiel, store it. This year is 2023, store that information. YOB, year of birth is 2012, store that information. Age is this year minus YOB. Do that calculation, do this calculation here, and whatever answer, whatever value you get, store it as the age. So we have 4 boxes. We're storing different things in, and this box contains an evaluation of a subtraction between this and that stored in that box. But realize that we're not referencing the actual numbers because we've already told the machine to remember these numbers. So we don't have to worry ahead over it. What we have to worry about is telling the machine what to do with those numbers. And in this case, we are saying in calculating the age, subtract year of birth from this year and store it in the box age, right? So the machine says, okay, I'm supposed to do this, then I'm supposed to do this, then I'm supposed to do this, then I'm supposed to do this. Then afterwards, I'm supposed to say, hey, my name is, and whichever name I've been told to store, I put that name at the end of that sentence, right? And then I'm supposed to say, I am, and then whichever age I've been given, I'm supposed to add that to that sentence. And then I'm supposed to say I was born in, and whichever year of birth I was given, I'm supposed to add to that sentence. And every time the information changes, I'm supposed to remember the new information and store it. So we're going to do that. We're going to test all these. We're going to play around with this before we start talking about the concepts. Now remember, this is a file we are creating. And so this file can be stored, right? This file can be, and I'll show you in your folder where that file is saved. And I'll show you that you can even run it outside of the code editor and it'll still work fine. Okay, so if you want to run this code, you can come here, up here,
Up where?
in the top,
Mhm.
up here, inside the, where you have the
Yeah.
tabs. You can come to the end where you have the play button,
Yeah.
and then you can hit run Python code.
Oh.
So if you do that, if you did everything right, you should say, hey, my name is Ezekiel. I am 11 years old. I was born in 2012.
Hey, my name is Sophia. Hey, is this error? Hey, hey.
It says error.
The first one came. Then
Please
it
share your
said, hey,
screen.
my name is Sophia. Then this year, then it says that fragment. I don't know.
Okay, all right. So you see, what your PC is doing is that it has stored all this and printed the first one. But what you are telling it to do in line 6, which is in your code,
Hmm.
it doesn't understand what you're saying. So let's go and check it. I'm going to stop sharing my screen. You share yours. I will try and identify the problem and we can go ahead.
Okay.
So please share your screen and let's look at your code.
Fine. Can you say it?
It's now loading.
What should I? Is it sharing? I
Yeah,
should.
Sharon.
Okay.
Can you please maximize your screen? Is it full screen? Yes, please maximize it.
I
Okay,
have.
awesome. So what happened here? I am mommy. So the problem is that you have told you to store it. So this is very case sensitive. You have told you to store age as capital AYGE, but you are
Ah,
calling age as small a GE.
okay.
So yes, so you can either change that to capital AGE or you can go and change the name.
Okay.
Yep.
Okay.
So now that you've changed it, click the play button again, click the run button again, and this time around, if everything goes right, it should do that. Another error. Yeah, it's done that now. You can see.
My
So
name.
right after the error, you can see
Oh,
that it
my.
says, "Hey, my name."
Yeah, 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 yeah. It's now
Yes.
up. Okay. Okay. Thank
Oh,
you.
pleasure.
So I
So
should
I'm
stop
going back to
here.
sharing my screen. Yes, please. Okay, all right. So if we all have it, please give me a thumbs up. I can't see your faces, so I don't know what is going on. Do any of us have any challenges right now at this point? Okay, all right, awesome. So yeah, baby steps, right? Baby steps. We are slowly learning how to give instructions to our PT. Now, while you might not understand everything that is going on and the technicalities behind it, trust me, these are the first steps, right? So now so I gave you two scenarios of writing or giving these instructions. You could give them one after the other and wait for the machine to follow it, or you could give all these instructions together before you run it. So remember that over here, when we were writing this Python script, which is what it's called, we didn't press enter for anything to happen. We wrote everything we needed the machine to do, and then we told the machine to now go and do it, now run the code, and that happened. Believe it or not, this code that you've written, you can run it in any environment that has a Python interpreter on it, right? So it doesn't have to be within your code editor, right? So if I close, minimize your code editor for a second. I want you to minimize it for a second, right? And I'm going to minimize my browser for a second. So if I minimize my code editor and I come to File Explorer and I come to Desktop and I come to PyTools, you can see there's a Python file. This is the file I created. It's stored in there as lesson one. Please go to your desktop, open the PyTools folder, go inside and make sure you have lesson one in there. Do we
Yeah,
all have that?
yeah.
Okay, all right. So here's the fun part. Whereas in the first part, we were writing all the code in the console and we had to wait for the code to be executed, we can save this particular code. And every time we want the machine to run to follow this particular instruction, we'll go in there, we'll tell the machine, follow this instruction, and it will do that. And in order to demonstrate that, you can go to the address bar at the top here, over here. Or no, let's use the simpler method. If you're using Windows 11, you can right click inside anywhere inside here. Sorry, you can right click on the file. What the option is gone. Ah, it's here. So if you're using Windows 11, you can right click anywhere inside this empty space and select Open in Terminal.
Okay.
Anywhere inside the empty space and select
That is
Open in Terminal. That is for Windows 11, right? If you're using Windows 10, you can go into the address bar at the top here, over here. Click it, make sure everything is highlighted, and type CMD. It will open command prompt inside this specific folder. And you're going to have the folder extension all the way to PyTools at the end here. So for those of us on Windows 11, you can just open this in terminal and you'll be fine. Is that okay?
Yes.
Please, are we okay? Can you see
Yeah.
PyTools? Can you see PyTools before the prompt? Okay. So now we're going to tell our machine to do something. We're going to say, we're going to call the Python interpreter by typing py over here. So we are letting our machine to open the Python interpreter, right? And we are going to press space. And we are going to tell our machine to go read lesson one, lesson1 dot py, that file, and execute any instructions that are in there. Please, do you have this typed out? Hello?
Yes.
Do you have this typed out? So we're going to say py space lesson1.py, or we're going to say Python. So you could use py or Python to invoke the Python interpreter, right? Space lesson1.py. So we are saying that look in this folder, look for the file called lesson1.py, and then follow the instructions that are in there. That's basically what we are saying. So we first
Okay.
call the Python interpreter, then we tell our machine to look inside this folder, look for lesson1.py, and execute that instruction. So if you hit enter, even though we are not inside our code editor, it's going to run the code and execute it.
Yeah.
Okay. I want you to press the up button again, the arrow up button. It should show the code again, and press it again. Press enter again. It will run the same code again.
Yeah.
If we close the terminal, unlike the first one, if we close the terminal and we open the terminal again in the same folder and we write the same code again and then we hit it, it should be able to run it. Why? Because,
It's safe.
or in a document called lesson1.py. And every time we tell our machine, first use the Python interpreter, now find lesson1.py and follow the instructions on it. It's like saying, first open Google Translate. Now find this Word document in Spanish, translate it, and follow the instructions, and show me what I need to see. So, congratulations. First Python code setup, understanding what programming is, giving instructions, basic concept, not basic concept, giving instructions and writing the instructions to a document that your computer can follow every time and execute is done. And believe it or not, you have written your first program. I know it's simple, I know it's straightforward, but believe it or not, you've written your first program, and from here on out, you can tell your machine to do much more complex things by referencing scripts and files and all those things that you do, right? Which is amazing. So yeah, this is the lesson for today.